Let's try to answer this question. Find f prime of x of f of x is equal to the absolute value of x using first principles. The definition of first principles is f prime of x is equal to limit as h approaches 0 f of x plus h minus f of x over h. We have f of x is equal to the absolute value of x. Now we're going to use a rather interesting understanding to solve this problem. The absolute value of x has two definitions. It has x if x is greater than or equal to 0 and negative x if x is less than 0. This is how come it always produces a positive answer, because when you put negative x, it will make it a positive number. Now, this is not the approach we're going to use in this scenario. It's possible to use it, but we'll use another method here. We use the understanding that the absolute value of x is equal to the square root of x squared. Now stay with me here. The absolute value of x always produces a positive number. If you put a negative, the output will always be a positive. Now, let's look at the square root of x squared and also the square root of x. Notice that if you put a negative number here, let's say -1, we get undefined. But if we put a negative number into the square root of x squared, we get the square root of -1 squared, which is the square root of a positive number, which is 1. And also let's check, if we put -1 into the absolute value, we get a positive. So these two are the same. That's how come the absolute value of x is also considered to be the square root of x squared. So this is the understanding that we're going to use to get f prime of x. With that in mind, let's get into it. Okay, we've established that the understanding that x, the absolute value of x, is equal to the square root of x squared. This is the understanding we'll use. Our f of x initially was the absolute value of x, but if these two are the same, that means that our f of x is now the square root of x squared, making our f of x plus h the square root of x plus h squared. Now be sure not to cancel the square root and the square symbol, because that defeats the whole purpose of us writing it in this way. We must keep it like this until a certain point. Okay, so let's plug in our f of x plus h. So this is limit as h approaches 0. Our f of x plus h is square root x plus h squared minus square root of x squared. This whole thing is divided by h. Now notice what happens if we plug in 0 into this function. We get division by 0, so we don't want to go ahead and apply the limit just now. What we want to do is simplify this in such a way that there's no h in the denominator. That will cause division by 0. So we multiply the top and bottom by the conjugate of the numerator. The conjugate being the square root of x plus h squared. Now the conjugate will change this middle symbol, so that's plus square root of x squared. The denominator also square root x plus h squared plus square root of x squared. After doing this, we can now expand the top. We multiply this term by this term by this last one by this one by this one. Now that's one way of doing it. The other way of doing it is using the understanding of the difference of two squares. If we have a minus b and a plus b. This is a squared minus b squared. This is the difference of two squared. Now, let's notice what we have here. We have the form a minus b, which is this part, and a plus b, which is this part. So if this is our a, and this is our b, our a, our b, the first part is a minus b, the second part is a plus b. That means that this result can be the same as a squared minus b squared, making this, if our a is x plus h, this whole thing is squared. Then minus from here, our b is the square root of x squared. Then we square this. This whole thing is over h, open brackets, square root x plus h squared plus square root of x squared, close. Limit as h approaches 0. Now, at this point, we can cancel these two, the square root and the square, making this x plus h squared minus x squared. This whole thing is over h, open brackets, the square root, x plus h squared plus square root of x squared. Limit h approaches 0. Now let's expand x plus h squared. This becomes x squared plus 2h plus h squared minus x squared over h square root x plus h squared plus x squared. Limit as h approaches 0. Now let's see if there are any terms that we can cancel or any terms that we can put together. We have x squared here. Do we have any other x squared? Yes, we do. Here. So, and this is negative x squared. So x squared and x squared can cancel, leaving us with 2xh plus h squared over h square root x plus h squared plus square root of x squared. Limit as h approaches 0. Now, let's factor out h in the numerator. If we factor out h in the numerator, we have h, open brackets, 2x plus h, open brackets, over h square root x plus h squared plus the square root of x squared. Limit as h approaches 0. At this point, we can cancel h in the numerator and h in the denominator, leaving us with 2x plus h over the square root of x plus h squared plus square root of x squared. Limit as h approaches 0. We can now apply the limit. We'll say when h approaches 0, we'll plug in 0 wherever we have h. So this is 2x plus 0 over the square root of x plus 0 squared plus square root of x squared. This is equal to 2x over x plus 0 is simply x, so this will be x squared plus x squared. Now we can add the denominator, so this will be 2x over 2 square root of x squared. We can cancel out the 2, leaving us with x over the square root of x squared. And this is our f prime of x. Now, one may ask, why can't we say x over and cancel the square root and the square symbol at this point so that it's x over x is equal to 1? Well, again, that would defeat the whole purpose of this. If we put -1 here, -1 over -1 will still give us a positive. But if we put -1 in this one, we'll get -1 over the square root of -1 squared, which is -1 over +1. This gives us negative. And remember, x over the square root of x squared, this bottom part here is the same as how we defined it earlier. So f prime of x can also be x over the modulus of x.